All right, we're at 4-1A today, synthetic division with polynomials. And so we're going to start off doing a long division problem like we were doing yesterday. We're going to divide x cubed plus 27 by x plus 3. Now there is a pattern for doing this if you remember the pattern, but the nice thing is if you don't remember the pattern, you can always do it with division. So yesterday we talked about the fact that if we're missing a squared term or a first degree term, or if anything in between the highest degree and the last number is missing, we just put in zero values. So I'm going to do a 0x squared plus a 0x and then plus 27 here, and we're going to go ahead and divide, and the whole idea here is to take the lead term on the inside divided by the lead term on the outside. That's x cubed divided by x, so that's going to give me x squared. That's going to be my first term up on top here is x squared. X squared times x is x cubed. X squared times 3 is positive 3x squared. And I put some parentheses around there, and I make sure that I subtract and distribute the negative. Now x cubed minus x cubed, that's pretty obvious, but 0x squared minus 3x squared is where it gets a little less obvious, so that's going to be negative 3x squared. I drop down the next term, plus 0x, and I start all over. Lead term on the inside, negative 3x squared divided by x on the outside. That equals negative 3x. So that's my next term up on top is negative 3x, and I multiply. Negative 3x times x is negative 3x squared. Negative 3x times positive 3 is negative 9x. Put some parentheses around there. Now, you can change the signs if you want to, but as long as you remember that everything's the opposite, once that negative distributes, the 3x squareds cancel each other out. The 0x adds a 9x, so this becomes 9x plus 27, and we've got one more go around. So we've got 9x on the inside divided by x on the outside. That gives me positive 9. There's my last term up on top. 9 times x is 9x. 9 times 3 is 27. And hopefully it makes sense that when you subtract all that, you will get a zero remainder. So how do we know if x plus 3 is a factor of x cubed plus 27? It is, yes, because x plus 3 divides evenly into x cubed plus 27. All right, so that's how we know when something divides evenly and then it's a factor. All right, so that's kind of an if-then statement. If it divides evenly, it's got to be a factor of whatever it was dividing into. All right, so synthetic division is another way to divide polynomials, but you can only do synthetic division when your factor on the outside is either x, and it can be plus or minus some value of h. Okay, so that h can be, you know, any number. Okay, usually it's some sort of an integer, positive, negative 1, 2, 3, 4, and that kind of thing. But if it's a 2x, okay, so if it was 2x minus 3, this does not work because the 2x in the front does not allow you to do that. You can make it work, it just takes a little more time to figure it out. So when we divide using synthetic division, the first thing we're going to do is we're going to write down the value of h. Okay, what is it that we're seeing in there, and then the coefficients of the polynomial itself, and these always go in descending order. All right, so just like yesterday when we did x cubed and x squared and x, and then the constant term, and in the warm-up today, same thing. So in order for me to find out what h is here, now I can't just look at this and say, oh, h is negative 4. What I actually want is I want the solution to this binomial right here. So really what I need to be thinking about in my head is x minus 4 equal to 0. If I solve that, I get x equals 4. All right, that's my h value. That's what I want to divide by. So it's a little different from long division in that sense that, you know, you're not using the number from the factor itself, you're actually using the solution to the factor. All right, we'll talk more about that later on. my polynomial is just the coefficients this time. So I don't put the x cubed, the x squared, and all that kind of stuff. I put 2, I put -7, I put -8, and +16. And I've got this little space kind of separated out by itself at the end here. That's where my remainder is going to end up. Okay? So just like in the warm-up, our remainder was 0. Sometimes we're going to get a 0 over here, and sometimes we're not. So here we go. Here's the steps on the left side. I'm going to talk through them. Step number 1 is to always bring down the first coefficient. Doesn't matter what it is. And then you're going to multiply this by whatever your h value was. In this case, you're going to multiply by 4. Okay, so that was the h value in this case. So 4 times 2 gives me 8. And so when I multiply, I'm trying to think how to do this. When I multiply 4 times 2, I'm going to bring that result up right here. And I'm going to add down the new column. -7 plus 8 is +1. And then I'm going to multiply 4 times 1. And that's going to give me 4 right here. And I'm going to add down the column. That's going to give me -4. 4 times -4. I'm going to multiply there. That's going to give me -16. I'm going to add down the column. And I end up with a 0 remainder. So just like when we wrote them out yesterday with the factor and the answer, okay, we're going to do the same thing here. What we're saying is that the polynomial 2x cubed minus 7x squared minus 8x plus 16 is divisible by x minus 4. Therefore, x minus 4 is a factor, okay? And what's left over here, if you look at this 2 that's out front, that's the beginning of my new polynomial. Now, it's got to be 2x to the something, so how do you know what the something is? You take 2x cubed and you divide it by x, and that's 2x squared. So that's what's left over here is 2x squared, and then I work my way down the list. Plus 1x, or plus x, and then minus 4. And if you were to multiply those two polynomials together, you would get what we started with right back here in the beginning. Okay? So, let's take a look at the next side here. See what we got going on. There we go. All right. So we're going to divide this one. You'll notice we have 5x cubed plus x squared. There's no x term in here, so we're going to have to put a placeholder in there. And then a minus 7. We're going to divide by x plus 1. So, you know, obviously once you get the hang of this, you don't have to really do this step. X plus 1 equal to 0. If I subtract 1 on both sides, I get x equals -1. That's the value that I'm going to be multiplying. All right. So inside, I've got a 5 next to the x cubed. I've got a 1 next to the x squared. I've got a 0 for the x position. And then that last term, that constant term, always gets its own separate little box out here for the remainder. Okay? So we're going to do the same thing. We're going to drop down the 5. We're going to multiply 5 times -1. That's going to give me -5. I'm going to add down the column. That's going to give me -4. I'm going to take that -4, multiply it by -1. That's +4. I'm going to add down the column. I'm going to multiply 4 times -1. That's going to give me -4. I'm going to add down the column. And this time, I have a remainder of -11, which tells me, all right, which means x plus 1 is not a factor, okay, of the original polynomial. But I can still write my answer just like I did yesterday. My answer, if you look at this 5 here, and we do what we did on the last one, 5x cubed divided by x is 5x squared. So this is 5x squared minus 4x plus 4. And then since I have a remainder, I can do one of two things. I can either write plus with a -11 over x plus 1, or I can just write minus 11 over x plus 1. Remainder over divisor. Okay? So that would be my answer for the division right there. You'll notice in number 3, it says to completely factor this polynomial using synthetic division, And then it gives me these two factors, x plus 4, x minus 1, and it tells me that I'm missing a factor here. All right? What this is basically saying here is that these are given factors. Given factors, which means they should divide evenly. Okay, so I should get a zero remainder because they're telling me in this statement that this thing has factors of x plus 4 and x minus 1. So I'm going to start off with the x plus 4. We're going to do x plus 4 equal to 0, which implies that x is equal to negative 4. I'm going to take my coefficients from my polynomial. That's going to be 3, 12, negative 5, negative 18, and positive 8. I'll draw my little L-shaped thingamajiggy here. I'm going to give that 8 its own little space for the remainder, which I know should be 0. Okay? Drop down the 3. Here we go. 3 times negative 4 is negative 12. So I get 0 right there. 0 times negative 4 is 0. I get negative 5 right here when I add. Negative 5 times negative 4 is positive 20. I add, I get positive 2. 2 times negative 4 is negative 8. And I get a 0 remainder. Which means what I have left here, okay, after my first division, I have 3x to the third power now. Now there's only one reason I'm going to put down the 0x squared in this one, and I'll show it to you in a minute here. Plus 0x squared minus 5x plus 2. So that would be the answer to the division with x plus 4. Okay, since x plus 4 divides evenly, we know it is a factor. All right, of the original polynomial. Now check it out. Now, if that's all I had to do, I would know that I have x plus 4 times 3x cubed plus 0x squared minus 5x plus 2. So if I was stopping, that would be my answer right there. One factor times the other factor. But now I want to take that new polynomial and I want to divide that new polynomial by the second factor, by x minus 1. And it should also go in evenly because I was told that x minus 1 is a factor. So we take x minus 1, we set it equal to 0, we add 1 to both sides, and we get x equals 1. We take the factors, or the coefficients, from our new polynomial. So 3, this is why I left the 0 in there, because I knew I was going to have to divide again, and I didn't want to miss it when I went to do the division here. All right? So drop down the first one, coefficient. 3 times 1 is 3. Add down the column, you get 3. 3 times 1 is 3. Add down the column, you get negative 2. Negative 2 times 1 is negative 2. 0 remainder. Perfect. That's what we want. So what I have left now is 3x squared plus 3x minus 2. And if you check that with some factoring methods, you're going to find out that that guy doesn't factor. So my factored form would be x plus 4 times x minus 1 times 3x squared plus 3x minus 2, and that polynomial would be completely factored. All right? Good luck with the homework.